Hi everyone. Today we'll be doing a presentation on using Python to increase the number of orders for a restaurant chain, showing specific recommendations and insights backed by analysis. The steps that we followed were data preprocessing, data visualization, and finally we'll have some recommendations as well. Towards the data preprocessing side, we included the 5 pickle files and used libraries such as pandas, matplotlib, numpy, and skippystats. Concepts such as merge, group by, geolocation, data manipulation, and t-test were used. For the visualization part, I hand it over to Sophia.
Thank you, Harsh. So we can see that the first thing we notice is the item's popularity. Items like roasted sweet potatoes, snap peas are clearly leading in popularity, reflecting the strong customer preference of these dishes. The chart shows a mix of vegetable-based dishes, protein-focused bowls like chair chicken market bowl, and side dishes indicating that customers' choices span various meal components. Additionally, the restaurant's performance based on items popularity shows that NYU restaurants significantly outperforms others in sales volumes. And Steele's red roasted potatoes, snap peas, and farm greens with mint are consistently the top selling items across all restaurants. Even when we look into the performance based on others, restaurants like Bryant Park is showing the lowest order amount, while restaurants like NYU Midtown and Williamsburg have exponentially high order volumes, as you can see in the number of audience following. Now passing over to Najar.
Thank you, Sophia. Now, this chart shows the monthly in orders. We see peak in February, October, and December, likely to tight promotions or seasonal depend. A dip in July suggests lower order due to off-season or holidays. Now I'm gonna give it to Fadlan.
Okay, thank you, Najar. Now let's dig deeper to the monthly order fluctuation in each restaurant from these line charts. It shows that orders significantly dropped in July, specifically in the Columbia and NYU restaurants, which are located near to the university areas. This is likely due to the summer holidays at the campus. Now, moving on to weekly orders fluctuation to see the performance of each restaurant based on the days of the week. It shows a constant order numbers overall in all restaurants. However, there are a significant drop in the weekends, especially in Midtown and Flatiron restaurants, and moreover, Bryant Park restaurants turns out to be closed on the weekends, which is an issue that is to be evaluated immediately. Now I pass it along to Harsh.
Thank you, Fadla. We performed a hypothesis test with the null hypothesis that the order volume is same during peak and non-peak hours, and the alternative hypothesis being that order volume is higher during peak hours, with the assumption that peak hours is between 6 p.m. to 8 p.m. The probability value that we obtained was 0.026, which is less than the alpha of 5%, which means that we rejected the null hypothesis and accepted the fact that order volume is higher during peak hours. I'll now hand it back to Fadla.
Okay, thank you, Harsh. Based on the hypothesis mentioned earlier, now we take a look at the histograms to see the hourly hours orders fluctuations. It shows that the peak orders happens between 12 to 1 p.m. and orders slightly rise again between 6 to 8 p.m., which is typically for restaurants' performance. Now I'll pass it my time to Najar.
Thank you. So now we're gonna go over all order type distribution. In-store orders make up 72% of total orders, with pickup at 17% and delivery at 11.4%. This shows a strong preference for in-store dining, but pickup in growing delivery and has potential for expansion. Now for the orders types per restaurant, NYU has the highest numbers of orders with a strong preference for pickup. Bryant Park and Columbia show a balance between in-store and pickup. Most restaurants have higher in-store orders, indicating a strong food traffic. And now we're gonna go through the recommendation.
Firstly, the marketing recommendations that we have are target promotions for pickup and delivery, where we focus on special offers to boost pickup and delivery orders, especially in locations like NYU, where the pickup is really high. Secondly, we have event-based marketing where we run promotions during high demand months like February, October, December to capitalize on seasonal demand. To speak more about the operations recommendations, I'll pass it over to Fatla.
Okay, thank you, Harsh. For operational purposes, we recommend to have additional operational days, uh, which Bryant Park should be open on the weekends to increase orders and maintaining customer base. Then we suggest to optimize pickup services by creating dedicated pickup zones and improve pickup times, especially at locations like NYU where pickup orders are high. We also suggest to enhance delivery efficiency by streamlining delivery routes and timing, especially in the high demand areas like NYU to ensure quicker service and customer satisfaction. Lastly, weekend performance evaluation should be conducted after the data showed low orders on the weekends, especially in Midtown and Flatiron, which should be investigated further. Now I pass it along to Sophie.
Thank you, Fadlan. Now getting into the menu optimization recommendations. One recommendation to be made is seasonal menu adjustments. Introduce seasonal or holiday themed menus to match demand peaks during like a month like December, and offer summer specials during low demand months like July. It's also crucial to highlight popular items. Feature the high item demands in marketing campaigns or as combos deals to drive more sales and revenue. Getting into the customer loyalty recommendation, it is crucial to optimize staffing during the peak hours between 12 to 1 and 6 to 8. It is essential to handle high order volumes, reduce the wait time, and ensure a seamless customer experience while enhancing operational efficiency. To further enhance engagement, we propose a loyalty program that rewards repeat pickup and delivery customers with points or discounts.
Thank you so much for your presentation. Now we're moving to the notebook reading.
Thank you, Sophia. I'll be going over the Jupyter notebook. On the left-hand side, we have the table of content. We have the data pre-processing stage firstly. We also did some descriptive statistics using the describe function. And then we use concepts like merge and group by to plot certain visualizations, such as top 10 restaurants by total orders, the top 10 most popular items, and then the top 10 restaurants with the top three items sold, to be exact. We also then use the datetime function to plot time-based fluctuations. The first one is the monthly number of orders per restaurant. You can also see a daily trend that we see, and we had some observations regarding the weekend observation. We also plotted the number of orders by hour, which show that the peak time was between 12 to 1 p.m. We also use ScatterGeo to plot the locations of the restaurant, but we didn't feel that it would be beneficial to be put in the presentation, but we have it here. We also have the overall order type distribution using a pie chart, and then a bar chart to display the spread across restaurants. Finally, we have the hypothesis testing as well, where we used the p-value of 0.26 to determine that the null hypothesis can be rejected and the order volume is higher during peak hours. Thank you and have a nice day.